Welcome to Vonometry, and this is the first episode of Physics on O Block. Today we're just going to go over the basic stuff you need to know in order to have an easier time learning physics. So this isn't really physics, but the math you need to know in order to actually do physics. If you get anything from this, I hope that you understand what SI units are, you understand significant figures, you get a little better at trigonometry, and you're better at algebra. You need to know algebra. That's just you just need to. Trigonometry, yeah, you need to know, but algebra is directly connected to it. So yeah. So what are SI units? They are a globally agreed upon system of measurements. We use these units because everyone agreed to, and that means that they're consistent because everybody uses them. Another reason is because they make math way easier, especially when it comes to conversions. So look at this, 14 grams, right? Well, if you're trying to convert that to kilograms, all you're doing is moving the decimal point, right? Now let's look at imperial units, which is what the United States uses. 0.494 ounces. If you want to turn that into pounds, that is 0.031 pounds. That means you're gonna have to do a lot more math just to get it to pounds. Nobody wants to do more math. Scientists are obsessed with efficiency. That's just for some reason they are. You can see this in every single thing, but I'll do one more. 3,000 grams to 3 kilograms. All you're doing is moving the decimal point 3 times to the left. That's so much easier than 105.82 ounces and converting that to 6.614 pounds. You have to do way more math here. It's just a lot easier with the metric system. And that's why the SI system it uses the metric system. And I'm aware SI has the word system in it. So these are the primary SI units. Really, you just need to know these symbols. Length is usually measured in m for meters, mass in kilograms, time in second, temperature in K, electric current in amp. I don't like reading off a presentation. I'd rather just improvise. So I'm just going to skip these two. And I'm skipping these two because light we cover way later. And chemistry is just, we don't deal with moles. Okay, that's a chemistry thing. We're better than that. So really, it's just length, mass, time, temperature, and electric current. You might see this like, well, electric current is more of a circuit thing. We see that a lot later, especially light is a lot later. But yeah, temperature, that's a thermodynamics thing, which is a little bit of chemistry, but I feel like that's also physics. And I hope to cover everything except moles in the future. So prefixes of SI units. These are most common prefixes you'll see, but really, I think it's mostly kilo, milli, centi, and honestly, that's it. Because I cannot say a single time I've heard a tera other than on tables like these. And all these do is tell you how much you're going to move the decimal point. Now, I'm going to tell you right now, this is the foundation of scientific notation. Because let's say you have a specific number like 5.7 or 1.9 or something. And actually, no, I'm sorry, a bigger number, 1900, right? Instead of writing those two zeros, you can literally just say times 10 to the second power. Or let's say you have something way bigger, right? A gigameter, or I don't know. I'm trying to use the big prefixes, but the point is, when you have a lot of zeros, it is easier to just say 10 to the negative 12th power or 10 to the 12th power because it saves space, right? Especially on paper, and we don't waste paper because we're digital. Okay, do some dimensional analysis before we get into the scientific notation stuff. And dimensional analysis is so important because it helps you with your conversions, and it's how you keep track of all the units. And I'm just gonna let you know, if you use the wrong units, you just get the question wrong, especially in free response, especially in chemistry, because for some reason they just care so much. So 120 seconds, 2 minutes. First, you start always by putting the number over 1, and you keep track of your units. Now you're going to multiply that by 1 minute over 60 seconds. Now, but I'm not going to try to make some like super big realization here, but let's just think about it, okay? You know that there's 60 seconds in a minute. Like, you just know. If you don't, that's a problem. But you know. So that means with 120 seconds, you have 2 minutes. So you know the end result's going to be 2, no matter what. But you don't really know how you get your units there. And that's what this is for. So you start with your number over 1, 120 seconds over 1. And you multiply that by the conversion rate, or the conversion factor, whatever you want to call it. However, that conversion thingy has to have the units on the denominator, or the opposite part of the fraction. Because what that does is it gives you 120 seconds times minutes. I'm sorry, hold on. 120 seconds times minutes over 60 seconds. Now, you're probably wondering, right? Why are you treating the units like a variable? Like an algebra, right? That's because they are. You're supposed to. But let's think about it. What's 2 divided by 2? That's 1. What's 4 divided by 4? That's 1. Anything divided by itself gives you 1. Now, that means we have this s divided by itself, so they cancel out, which means you're not multiplying it by anything, right? So you can take out that multiplication sign. And that gives you, what's 120 over 60? That's 2, right? 2 minutes. That's what that gives you. That's what you do with dimensional analysis. You're keeping track of your units. And to get the units you want, everything else has to cancel out. And I promise you're going to get some weird stuff. You're going to get seconds times minutes, times hours, times minutes, times, I don't know, decades, whatever they give you. Point is, when you have a conversion factor, remember to keep your variables on opposite sides of the fraction, so that way they cancel out. We'll get better at this, so don't be too worried, because if it makes you feel better, I'm not. All right. Whoa. All right. Now I'm gonna move it back again. Here you go. Okay. Yeah. So let's not worry too much about it. Now let's do 5 kilometers to a meter, and I'm using the prefix k because we know that. Okay, no we don't because I erased it. We know that, right? 10 meters. How many kilometers are in a meter? Or I guess how many meters are in a kilometer? 1,000 meters make up a kilometer. That's our conversion rate. But what do we start with? We always put the number over 1. Then you multiply it. I do dots. I don't use X just because of calculus. It really confused me when I use X. So I use dots, okay? Now, what's our conversion factor? 1,000 meters for every kilometer, right? Well, remember, we have kilometer up here. So we can't have it. We can't have it like this, right? Because that doesn't cancel out the kilometers. However, this does, right? So just by that alone, that gives us, well, not blue, use red. That gives us 5,000 meters, which I'll write here. Or, hold on, because I'll go back a step just so you don't get too confused or anything. That's 5,000 km times the meters, right? Because you have the km there and the meters there, and you combine these to get the 5,000, right? Then you divide by Well, what's 1 times 1? It's 1. So it's 1 km. And we know that a number or anything divided by itself cancels out to 1. So, boom, boom, you're left with 5,000 meters. I need better handwriting. 5,000 meters over 1, which is equal to 5,000 meters. There you go. Now I'm going to speed through the next ones because I'm kind of like wasting your time. I'm sorry for that. All right, 250 millimeters, 250 milliliters over 1 times the conversion factor. It is 1,000 milliliters in a liter because that's what milli means. So it is, what is that? 1 liter for every 1,000 milliliters. And we need the variables and the units on the opposite side of the fraction, right? That gives you 250. Oh my, times liters times 1,000 milliliters. Cancels out, gives you 250. Wow, I am 50 liters over 1,000, which is equal to, I can't think right now, so calculator time. 0.25. We could be using significant figures right now, but we're not going to do that because I'm going to be honest, I don't want to. All right, same thing here. Kilograms, right? 3.2 kg over 1 times, how many are in a gram? 1,000 grams for every 1 kilogram. I'm not going to waste space rewriting it, so that cancels out. Because that's a 1, it's already assumed that. So what's 3.2 times 1,000? That is 3,200 grams. Notice how fast that was? You're going to get faster over time because you have to be for the AP test. All right, next. 8 inches over 1 times how many centimeters are in an inch? In an inch? 2.54 over 1 inch. Cancels out. 1 is always assumed to be there. What's 8 times 2.54? 20.32. cm. And there you go. You will get faster. I promise you will. All right. Hold on. Okay. ChatGPT doesn't want to work. It's fine. I don't need it. We want to put 4,500 in scientific notation. Now, with scientific notation, the decimal always usually just wants to be. It's usually uh 2 digits you have. So yeah, just go based off that logic. So we know the decimal point's right here. How do we get here? Well, you move the decimal point 3 times. 1, 2, 3. So we know it's 4.5 times 10, and that 10 represents the amount of times we move the decimal point. If we move it to the right, it's going to be a 1. If we move the decimal point to the left, it's going to be a -1. Here, we are to get that 4.5 to 4,500, you have to move it to the right 3 times. So it's 10 to the power 3. So let's think about it. You move it to the right once, that is 45, which would be the same thing as 4.5 times 10 to the, oh yeah, 1 power. You move it to the right twice, that is 4,500, which is the same thing as 4.5 times 10 to the second power. And then we get 4,500. I'm sorry, did I say that for 450? Ignore that. You get 4,500, which is the same as 4.5 times 10 to the third power, which is what we did. So you really just got to use that logic. Here, 5.6. How many times do you move it? 1, 2, 3, 4 times 10 to the negative 4. Boom. I'm going to use my calculator to make sure that's right. Yep, it is. All right, good. Out here, we got 3.2. How do we get that here? Well, 1, 2, 3 times 10 to the negative 3. Boom. It is that fast. 8.9 times 10. How many times? Well, 1, 2, 3, 4, 5. So 10 to the fifth power. If you want to check this, just do it with a calculator. I promise. All right, 4.2. All right, see, 1, 2, 3, 4, 5, 6. So to get that 4.2 to the whatever decimal point, you multiply it by 10, right? It's always by 10 with scientific notation, and you just move it to the right the exact amount of times, right? 1, 2, 3, 4, 5, 6 times negative 6, and there you go. That's it. This is really easy. It will get easier, I promise. So, what are significant figures? Really, all they do is tell us how accurate a measurement is. So let's look at 80. Okay, I need to get better at circling stuff. Alright, so let's that. Let's look at 82. I'll draw a line right here. So we can accurately say it's 80 to 82. We can't say it's 81.9995478. We can't say there's a specific decimal value to it because this thermometer does not measure that far. There's no little notch that says that, so we can't say it is without having a little part of us thinking that we're lying. But if we were to say, like, let's say it's at the 80 line and we say it's 80, we're confident. There's no room for uncertainty because we know it's at 80. So that's really what significant figures tell us. If we have two significant figures, the 8 and the 0, well, imagine there's a decimal point here, but 80, that means it is accurate up to two figures. That's really all significant figures do. Now, another thing you're supposed to know is accuracy and precision. Accuracy is just being correct, meaning you're getting the right answer. Precision means that, let's say you take a bunch of measurements, so the same thing. Precision, being precise, means that you're getting similar results, similar measurements every time. And I'll go more in depth about this now. Four rules you need to know for significant figures alone, just to find out how many significant figures are in a number. And that is that non-zero digits are always going to be significant, no matter what. So any number between 1 and 9 will be considered significant. Zeros between non-zero digits are significant. So whether you have 1,000,001 or 1,005, all those numbers will be significant. And you count them up, and that's how many significant figures you have. So in 1,005, you have four significant figures. I'm not gonna go ahead and count every zero in 1,000,001 because that's a lot of work. But the point is, you have how many ever numbers are in that as the amount of significant figures you have. Both three would be leading zeros are not significant. So zeros that are before non-zero digits are not going to be significant. So for example, you have 0.0042. That has two significant figures because the zeros in front of it or the zeros before it have to be there whether they're accurate or not. So you say they're not significant because you can never know. So yeah, they just have two significant figures because they have the two non-zero digits. The last rule is that trailing zeros are significant if there's a decimal point. That decimal point is the guide, right? It just changes everything. So if you have 50.0, that's three significant figures because that decimal point is saying that those two zeros are accurate and it knows that for a fact. But if you just have 500, and there's no decimal point, then you really only have that one significant figure there, right? Because those zeros, you don't know if they're accurate or not. So you just have to assume they're not, and therefore they're not significant, and you only have one significant figure with that 5. Now, it would be different if it was written as 5.00 times 10 to the second power, because notice how these numbers, well, actually, 500 at 5.00 times 10 to the second power have the same value. But this 5.00 tells us how many significant figures are in the scientific notation. So 5.00 times 10 to the second power gives us 500, except this means that decimal point means is 3 significant figures. And this is just scientific notation because it's meant to like shorten how much space you use, but really here it's just trying to be smart. Now there's two rules for the operation of significant figures. For addition and subtraction, you round to the least number of decimal places. And that makes sense because you're rounding based off your least accurate number. Multiplication and division is the same logic. You just round to the least number of significant figures. Because you base your result and you round it based off the least accurate number you have, which the least accurate number would have the least number of significant figures. And we're going to do more examples right now. All right, so let's do some significant figure examples. How many significant figures are in 0.00456? Now, immediately, just by looking at the number, we know there's at least 3, because these are the value of 1 through 9, right? 4 is between 1 and 9, 5 is between 1 and 9, 6 is between 1 and 9. But what about these 3 zeros? Well, because they're leading, they are not significant. Remember, you have to put these zeros here no matter what if you want to represent this number. So you cannot tell if it's significant. You can't tell if it's accurate or not. So you just say they're not significant. So 3 significant figures. What about 6.780? Well, immediately we know there's at least 3, right? So what about that 0? Well, let's think about it. You don't have to put that 0 there, right? But they did. And trailing zeros after a decimal point are significant. They didn't have to put the 0 there, but they did, which means they know it was accurate for a fact. So it is 4 significant figures. What about 502,000? Okay, I was expecting to read more of the number, but it's just 502,000. Well, we know that there's at least 2, right? What about the 0 in between for the 5 and the 2? Well, because it's between 2 non-zero numbers, this is significant. So all these 3 are significant. Now let's look at the rest of the zeros, right? Well, remember what I said about the decimal point? That changes everything. There is not a decimal point here. So we cannot assume that those zeros are accurate or not, because if you wanted to write down 502,000, you have to put those zeros there, whether they're accurate or they're not. So these are not significant, and it has 3 significant figures. Let's look at 0.07080. We know that the 7 and the 8 are significant. We know that the 0 in between these two numbers, the 7 and the 8, are significant because it's between 2 non-zero numbers. Now, remember the first one we did? Leading zeros aren't significant. Why? Because you have to put these zeros here no matter what if you want to write down this number. However, you don't need that 0 at the end. I shouldn't have done that. There you go. You didn't need the 0, but they put it there because they know it is accurate, which means that it's significant. So it has 4 significant figures. Now let's do some rounding. All right. So we want to round to 3 significant figures, right? Oh, I can do that. Oh, okay. We want to round to 3 significant figures. This is 4 already. So all you gotta do is round. Hopefully you know how to round, but if it's 5 or above, you just add 1 to the previous decimal point. Previous digit space, I'm sorry. So we know the first 2 are just gonna stay there. 89. What does that round to? it rounds to 90 because that 9 is above a 5, so you turn it to 0 and add 1 to the next one. Only thing is, what do we do with the 0, right? We want 3 significant figures. Well, you round it. You can just take away that 0. There you go. So you have 0.00679. These zeros are not significant because you have to put them there no matter what. All right, let's do 12,345. Well, these two are basically stuck there. You can't do anything about them because they just have to be there if you want your number there. But what about this 345? Well, because you need to, since these are 2 significant figures, this needs to be 1. So you got to cancel out this 45, and you do that by either rounding up or down to 3. Now, 4 is less than 5. So because 4 is less than 5, you do not turn it to 0 and add 1 to the 3. You turn it to 0, and that's it. So you got 12,300. I need to get better handwriting. Okay, I gotta stop or I'll keep doing it forever. Now, let's look at this 3 significant figures, right? And because there's no decimal point here, those 2 zeros don't count. So they're just there. They're not significant. So you have 3 significant figures. Let's do it with the next one. All right. Immediately, we know these 4 are not significant because they have to be there no matter what. So now we're just dealing with this group of numbers. Now, we want to keep it as close to their value as we can, right? When we round. So 98, yeah, that stays. But we want 3, right? So since this is 2, we got to turn this 765 into one significant figure. Now that determining factor, why? That determining factor is all based around this 6. Is 6 greater than 5? Yes, it is. So because 6 is greater than 5, it is 0.000988. House. All right, and that's it. Because you cancel out the 65 and you round it up. And those zeros are not significant because they're just there. You have to put them there no matter what. Some would say they're leading, but that's weird phrasing. Now 567.89. That's a number, all right. Well, 560. You're gonna want to keep that there just because it keeps it closest to the original value. But the 7.89. Well, since this is 2 significant figures, you need to turn this into 1. Now, you would keep it closest to the original value. Oh no. By rounding that 89 up to the 7, right? Is 8 greater than or less than 5? It is greater than. So you're going to turn that 8 into a 0. You're going to turn the 89 into a 0. Then you're going to add 1 to that 7. So it's 568. And there you go, 3 significant figures. I'm sorry if I'm being confusing at all. This is my first time recording this. And it is 2:13 a.m. I'm tired. Alright, next is this actually might give me a little trouble. Well, multiplication. I'm a nerd, so I have a calculator, but if you don't get one, you need it for physics. Alright, multiplication, immediately we know you go based off the one with the least significant figures. 4.1 and yeah, 4.1. 4.1 is 2 significant figures. 3.26 is 3 significant figures. So you're going to go based off the 2 significant figures, and you get your calculator and put 3.26 times 4.1. Now, you're going to put the total, 13.366. However, you need to round, right? Well, you have to get it to the 2 significant figure spot. So 13.366, you round that. What's 3? Is that greater than or less than 5? It is less than. So your rounded calculation should end in 13. Now, let's do some addition. I like addition way more. First of all, you go based off the least decimal places, right? So this is 2, this is 3, which is less, 2 or 3? 2, right? So just by that alone, we know you'll have 2 decimal places. Now, let's use our calculator to add them. All right, that gives you 18.018. Now you gotta round the decimal place to choose 2 places, right? 2 spaces. So we know that 18 stays because we don't care about the anything after the decimal point. We care about everything less than it. So 0, 1, 8. How do you get that to 2 places? Two digits. Well, is 8 greater than or equal to 1? I mean, is 8 greater than or less than 5? It is greater than. So you're going to leave that 0 and you're going to put 2 because you turn that 8 into a 0 and you add 1 to the next digit. So 18.02. All right, for this one, this is 2 significant figures. This is 3 significant figures. Put it in your calculator. 730.994152. You round to the least significant figures, which is 2. So it's 730. There you go. Good enough. I'm sorry, I'm tired. Next one. All right, 3 decimal places, 2 decimal places. That alone tells us that our end result will have 2 digits in the decimal place, right? Good. We're there. All right. Let's do it. 105.607 minus 2.31 gives us 103.297. And we round to the decimal place, right? So 103 stays there. 297, what does that round to? Well, 7 is greater than, I'm sorry, that looks like a 2. All right, 7 is greater than 5, so you add 1 to the 9, and the 9, when you add 1 to that, it gives you 10. So it's 103.30. There you go. Because that 0, you don't have to put it there. But you did, because it's accurate, which means it's significant. And you know it's significant because it's accurate. There you go. All right, is that it? Oh, thank you. There you go. Now we're getting into the slightly more complicated stuff of physics. We're doing trigonometry, which you see a lot of this in pre-calculus, but not everybody wants to be super smart and take pre-calculus or calculus or anything like that. Point here is that SOHCAHTOA. This is extremely helpful, and this is what it gets you. It gets you sine equals opposite of hypotenuse. I'm sorry. Sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. Tan theta equals opposite over adjacent. Now you're probably wondering, what are all these words? Sine, cosine, and tan are trigonometric functions. They're in your calculator. That's all you need to know. Opposite, hypotenuse, adjacent. What is that? First, let's look at theta. What does theta mean? Theta is the variable symbol for an angle. So the angle from here to here is theta. Now we don't know what theta is, but we could say it's 40 or 50 or 60 or 70. It'll either give it to you in a problem when you need it, or it'll give you a way to solve for it. But how do you solve for it? Well, if you know the hypotenuse and the opposite, well, then you can use this one, right? You can just say that, well, you need to learn the anti-trigonometric functions, which we'll go over later. But the point is, you can just say it's arc sine equals opposite, or I'm sorry, arc sine of opposite over hypotenuse equals theta. I will go more in depth over all these 3 in a little bit because we're going to do some examples with them, because I don't want to say more words that are confusing for no reason. However, I do think it's important you know how to identify the opposite, hypotenuse, and adjacent sides. In a triangle or a right triangle, you will see this little square symbol on the bottom or on a specific corner. That is how you'll identify hypotenuse, adjacent, opposite. You use this and theta. So the side opposite of theta is the opposite side. The side opposite of this little square, like directly in front of it, is the hypotenuse. And then the side right next to the theta is adjacent. And we'll do more examples in a bit. But first, let's talk about vectors. Trigonometry really helps you do a lot with vectors and get more information from them. But first, in order to know what a vector is, you need to know what a magnitude is. A magnitude is a size or absolute value of a quantity. Put simply, it's just a positive number. Magnitudes have to be positive. I'll just remember that and you'll be fine with magnitudes. And a scalar is a quantity that only has a magnitude. Excuse that voice crack. What only has a positive number to measure it? Well, time, because you can't go back in time yet. Mass, because you can't just weigh less. You can't have a negative mass. I'm sorry, I'm using more words than I need to, and I'm confusing myself. You can't have a negative mass, so it has to be a scalar. Now let's talk about vectors. These are literally the entirety of physics. You will constantly see these, and hopefully you won't get annoyed by them. You'll just know what to do with them. A vector is a quantity with a magnitude and a direction. Time, you can only measure it with a positive number, right? Mass doesn't have a direction, and you have to measure it with a positive number. However, a vector, for example, velocity. Velocity is a measurement of the change in position, which we'll go over all the kinematics in the next video, I promise, because I need to learn it too. But a vector is a magnitude and a direction. So it's a number that goes in a specific direction. So let's say we're talking about velocity, right? If your velocity says you're moving forward, we're going to say forward is the positive direction. And we'll say 40 miles per hour. Oh, I'm sorry, we use SI here. 40 kilometers an hour. Now, let's say we're moving backwards at 40 kilometers an hour. Well, then we're going to say negative 40 kilometers an hour. I'm not going to write kilometers an hour because my handwriting is terrible. But the point is that negative or positive sign is a huge characteristic of a vector. And you know the second you see a negative or positive sign and a kilometers an hour or a unit of measurement, it's a vector. We will deal with vectors constantly. Now, the way we represent vectors in AP Physics is usually arrows. And the length of the arrow is the magnitude of it. Because remember, a vector is a magnitude and a direction. And this little theta symbol right here is a direction. Because it tells us the angle at which that magnitude is moving. So the direction is usually pretty obvious. In this case, it's the direction of mark. Now, vector components. We could just draw a line right here and measure it. But let's say you're on paper, you don't have a ruler, you don't have it. However, you know how far it travels on the x-axis and how far it travels on the y-axis. Well, with that, you can do a little more. If you know the x and the y values of the vector, the x and y components, which I will go over a lot more in the future because you need to have a better understanding of that. But if you know the x and the y components, you can use Pythagorean's theorem to get the z component. Same applies for any of the other side. If you know the z and the y components, and like the question is like, how far did it travel on the horizontal plane? Well, if you know the z and the y components, you can use Pythagorean's theorem and find x. That's all you really need to know with components. They are just the specific parts of a vector. I'm gonna be risky here and not look at the answers at all and hope I'm correct. So the vector, the green right here, is 10 whatever long. And we know the angle at which it is moving away from the x-axis is 30 degrees. That alone is enough to find the x and the y value. So let's figure it out. I'm going to redraw this triangle. This is the 10. We know this is a right angle. Now, the little square on the bottom right of the triangle it means it's a right angle. That's really important because that's how we determine every side of it. So 10 is the hypotenuse because it's the side opposite of that little square. Theta, whatever side's opposite of that, is the opposite angle. You know, I shouldn't have done that. And then whatever's left is the adjacent. And also because it's right next to theta, so it's like adjacent to theta. I'm going to go ahead and do that with all of them, just so it makes it easier for me. And this is what I do, and I recommend you do it too. All right, 15 is the hypotenuse, theta, so this is adjacent and opposite. You'll get faster with it over time, I promise. Boom, boom. 12 hypotenuse, up, adjacent. All right, there you go, we're good. All right, let's do it. So we have the hypotenuse and we have theta. So that alone means we can't use 10 because we don't have opposite or adjacent. It wants us to find that. But because we have hypotenuse and because we have the angle, which is 30, sine of 30 is equal to opposite is y, adjacent is x. Let's make that clear, right? Because this is on the x-axis and this is on the y-axis. That's the logic there. So sine of 30 is equal to y over, I'm sorry, 10. Now you're going to use your calculator, sine of 30, or if you know the unit circle, it's just 0.5. So 0.5 is equal to y over 10, which means you multiply by 10, you multiply by 10, which gives you 5 is equal to y. So the y component of this whole vector is 5. So let's find x. Well, cosine of 30 is equal to adjacent, or x, over hypotenuse, which is 10. Cosine of 30, I should really learn the unit circle. 0.86602. Yeah, you know what? Yeah, we gotta do this. I was gonna try to be smart and think of another way, but you just gotta do it. 0.4. You do not have to be how I do it. You do not have to do all that. You could just write like the first few digits and you'll be fine. But I do it like this because it makes me feel better about myself. So times 10 times 10, which is 8.6602544 go to x. And there you go. We found the y component and we found the x component just by having the hypotenuse and the theta. So I'm gonna do one more because I don't want to waste more of your time. Let's see which ones. I don't like 45, so I'm gonna do this one. We know the hypotenuse is 12. Let's use this little. I'm gonna move this here because. Okay, go ahead and just don't do that. Uh, oh my, s of theta. S means sine. So up over hypotenuse. Co of theta. Ka. So it's adjacent over hypotenuse. And toe of theta, so t theta. Do not write SCT like that. You don't. You just write it as sine cosine theta or sine cosine tan, but I'm different. And I kind of don't remember it off the back of my head. Okay, we know the hypotenuse is 12, so sine of 60 is equal to y over 12. What is sine of 60? Times 12. All right. There you go. That's it. I got the sine of 60. I multiplied it by 12. And that's it. And you multiply it by 12 because that's how you cancel out the y over 12. Because let's think about it, right? You got, well, just do it. Y over 12. If you multiply it by 12, then that's 12y over 12, which just cancels out and it gives you 1, or it gives you y. Well, 1 times y, which is y. And what you do to one side, you do to the other. So you have to multiply this side by it as well. So it's 12, 12. I'm going to go ahead and erase all that because yellow's ugly. But hopefully you get the point. I'm not going to make videos on algebra. I'm going to make videos on physics. So if you need help with algebra, go look at like Math Antics or something. Not in the mean way. All right. Now let's do cosine of 60 is equal to x over 12. You could be proactive and do it like this. That's what the cool kids do, but you're not one of them. All right, now you got 6 equals x. There you go. I did not put the example questions for Pythagorean theorem. Great. I'll do it right now. X point of that, one of that. Okay. If we know this is A and this is 6, find Z and excuse my triangles. All right. If you want to find Z, you got to use this. A squared plus B squared equals C squared. What don't we have? We do not have theta, right? That's why you have to use Pythagorean's theorem. It's as simple as that. You have to use it. And another thing, you're supposed to put an arrow right here to like emphasize that it is a vector. Because these are vectors, right? Because it has the x direction, y direction. It has a direction, it has a magnitude. We know it has a magnitude because we spent so much time calculating them because you're a nerd. And yeah, so you're supposed to put this arrow here. So when you're on the free response questions, please remember that, because if you don't, then you'll do bad. And I don't want you to do bad. So x value is 8 squared. Well, x value is 8, so you square it. What's 6? It's 6. And you square it. And that equals c squared. So it's 64 plus 36 equals c squared, which is equal to 0. 100 is equal to c squared. You square root it, you get c is equal to 10. Well, plus minus 10, technically. However, in physics, we don't use the negative. We don't use that negative. So just take that negative out. There you go, 10. Let's do it again. 3 squared plus 4 squared equals c squared. Can my laptop stop trying to turn off? What's 3 squared? It's 9 plus 16 is equal to c squared. 25 is equal to 25 is equal to c squared. Square root, c equals 5 plus minus. Ignore that because you know there's no minus, so it's 5. Now, I promise you, you are going to need to use this. Every single thing you've gone over, you're going to need to use it. So please get comfortable with it. I did more than most people do because some people don't like to put examples. They just like to say they go over it by like telling you how to do it. That doesn't work. I know it doesn't because I'm a student too. So I really hope this helped. And yeah, I hope you understood it.